Quasar E-Motorsports. What's up guys, this is Quasar, and this is going to be our next build. This is a 1978 Pannonia sidecar motorcycle, and the coolest part is the customer found us on the channel. We're going to be converting this to electric. He's already done the powder coat and the upholstery. The wheels are going to need some love. We're going to use an Electro and Co powertrain apart from the battery, which I'll be building myself. We're going with the QS138 V3 motor and the Votol Em260s SP controller. We'll be gearing it for about 50 miles an hour, maybe 40 horsepower, which is a lot more than they had prior. Sidecars are pretty dangerous, and that's why you don't see them very often, so we don't want it to go too fast. The first order of business is going to be to remove the sidecar. So we've got the sidecar removed. Now we're going to check out motor fitment. We're going to see how this lines up and what type of bracketry we're going to need to make to be able to get it to fit. Alright guys, so this build is going to be considerably more complicated than I originally thought. You'll notice that axle is stationary. There's no way to tension the chain on this bike. We're going to have to make the motor capable of pivoting within the mounts. I've come up with a good way to do it. What I'm going to do is I'm going to take a mount here to here and make that the pivot mount. I made this custom left and right hand threaded Heim turnbuckle. It's going to go up in here for this part right here. And then I have this turnbuckle for the pull. This is good for 7,700 pound working load. It's stainless steel made in America. Made sure I got a good one, not a Chinese one. And we're going to go from right there to about right there. So this one is going to pull and the other one is going to push. And that's going to be our pivot point right here. So that's going to be what makes the motor able to pivot so we can tighten the chain and also locks it down. And then we're going to have to figure out how we're going to mount the battery tray above all this stuff to make it work. Also, you'll notice there's a bunch of oil down here. So in order to get the QS138 V3 70H to run in reverse, there's a couple modifications we're going to have to do. I took the cover off. That way I can check out the gears because they are helical cut gears. Helical cut gears can run forward or reverse. However, you have to take note on the direction in which they push or pull each other. After I pulled this part from the factory, the motor rotor will push out towards the case, and this part of the deal here will suck into the case. If we did not have the ENC billet cover, I'd be a little bit more concerned about that running in reverse. You can run these in reverse, but it's not suggested by Psychosis to run them in full power in reverse at a normal rate. However, because we have this billet cover, I'm not concerned about it. I've inspected it. It's really thick. There's not a whole lot of axial force on that. There is a bit, but it's not a huge amount, so I'm not concerned about that part. The biggest part is the breather. So you'll notice the breather line here. This actually goes down here, which would be the top of the motor. So right now, all the oil is at the breather. So if we were to run this in reverse in this situation right here, any buildup of pressure in here would shoot the oil straight out of the breather. So what we're going to do is we're going to tap in a new breather at the top of the case up here, up by here, but it's going to breathe from the top right here, and it's going to go up into an oil catch can, which I'm going to put somewhere over here. So any oil that shoots out of there is going to go up and just come right back down. Then that'll let the case breathe and everything will be fine. We're going to keep this blocked off. Normally when you run these, you're going to open that up because you don't want the pressure to build up. Because it'll push the oil into the seals inside the rotor, or it could burst this seal here. So a breather is very important because when you start getting hot and high temperatures in here, oil expands, the oxygen or atmosphere or whatever's in there will expand, and it's going to push the oil wherever it can, and if it has nowhere to go, it's going to go through the seals. So that's why they have a breather. This is also why Psychosis recommends not to run it in reverse on high power stuff. Generally they just say don't do it. Obviously you can run this in reverse, but you wouldn't want to run it as a primary in reverse because of the breather, and probably partially because of the original case was not very strong. This is the second iteration. They have larger bearings, a reinforced case. I think even the non-CNC cases would probably be fine. There are a few people who are doing it and they don't have issues, and they keep this blocked off and they don't have issues that they know of. I don't want the oil to bleed into the rotor. It's not supposed to be in there. Probably won't hurt it, but we'd lose the oil and we wouldn't know. So that's not a good idea. So we'll be redirecting the breather up here. I've already taken it apart and look. That's why there's oil down here. is I did not put the gasket back in there because I'm just fitting it. I don't really care right now. We're going to put new oil in there. We're also going to use an oil additive called Pro Lube, which is incredible stuff. I mean, when you add that stuff to a friction bearing, even with Lucas or the best oils, it completely stops all chatter and it'll stop it from smoking. It's incredible stuff. So we're going to run some Pro Lube in here and fix the breather, and I think that will that'll solve any issues we might have. And again, the CNC cover, I'm not at all worried about it. This is really thick inside, it's really well reinforced, and it is made from a piece of billet, so that will solve our issues.
What we're going to do is we're going to tap into the case up here, and we're going to get the air vent up here, and this is going to go up this rubber line into this air filter, and any oil that travels up will just travel right back down. It's not going to blow out because the vent's going to be directly in the top. So essentially this is just going to be our new vent. So we're going to go ahead and take this apart and get that going. Now for this part we need a flathead screwdriver or something usually to try to wiggle this case out. So let me grab one. Sorry for the audio change. It's raining like crazy here and I don't want to take a day off. So I'm using the DJI mic right now, and hopefully it sounds pretty decent. So we're going to go and pop this cover off. And really what you want to make sure you don't do is use a screwdriver and twist and pry on any of these sealing surfaces. This very outside surface is not a sealing surface, so that's safe. And there's also a tab right here you can use. And just be real gentle. I'm going to wiggle it up. And there we've got it. And as I explained before, I'm not too concerned about doing this because we have a really nice CNC cover from Electro and Co. This is their cover. It's nice and thick. It's well reinforced. The bearing housings are really wide, nice and thick. Looks like about 5 millimeters. I'm assuming that's probably at least 60-61 or maybe even 70-75 aluminum. And it's from a billet solid piece. So that's going to be great. Go ahead and set that aside. Let me grab a couple paper towels. All right. We're going to replace all this oil in here too. And I've already scraped the gasket off. And like I said, I did kind of put this in there, but it was not sealing well. So it leaked on the cardboard on the bike, which is not a big deal. Okay, so what we're going to do, actually before that, you can see this is the normal orientation that the motor's run in. And the vent too might be at the bottom, but it comes around the top. And the air goes through these baffles, which you can't see any. There's like a port here, but the other baffling from here to there is actually on the front case. So what we're going to do is, because we're going to run this motor like this, we're going to come in right here. We're going to bring in, so let me grab this tube. We're going to come in right here and bring our vent in like this. And we're going to go ahead and silicone that in with some really, really good automotive stuff. This is the right stuff. It's like $40 for a can like this. It's not cheap, but that stuff is amazing. I've already tested it on this type of hose. It sticks really good. This will stick to silicone, pretty much everything. Let me just show you. I tested a piece of silicone just to check. So actually, this is not silicone. This is Tygon, which is even slipperier. So I let that dry overnight, and I mean, it's not, no matter what you do, it is not coming off. And this stuff is a super firm gasket maker. So whatever gasket you make with it, it's not blowing out. I mean, if you've got huge pressure, it might, but this is not going to have any pressure in it really, because we're putting that vent. So we're just going to come in right here and come out right there. So we're going to use our die grinder. We're going to get those holes the right size. That way we have a top vent. And anyone wanting to run this motor in reverse can do the same thing. Now, I wouldn't recommend that you run the QS13870H in reverse without getting the Electro and Co. CNC machine front case. I think that's a pivotal part here. You have these axial loads, which I may have discussed before. When you have helical cut gears, they tend to push in one direction or the other based on the rotation. And it's not a huge amount of load, but it's moderate, you know. It depends on how much power is going through the shaft. However, originally this motor running in the proper direction, this rotor will push out, and the main gear right here that goes to the sprocket will push into the case, and you've got all the case back here to beef that up. That inward pushing though is a lot different than it pushing outward. So when it pushes outwards, you're going to have to rely on the case, all these bolts, and the thickness and strength of the case to hold that in there. And mind you too, you're also getting a pulling force from the chain and a rotational, another axial force there. So again, really nice thick machine cover. It's going to be just fine. I mean, they do this in gearboxes, and gearboxes are made out of the same stuff, so they're engineered for it, but I think that's good after looking at it. Anyhow, so we're going to go ahead and take the die grinder, and we're going to port this out here. I'm going to remove all this oil first, that way we don't have to get that full of aluminum chips. Okay, let's check the fitment. We'll go ahead and use the gasket maker and seal that in, and we've got a top vent. Okay, so I've been really liberal with the gasket maker. I filled that area up a bit. I filled all the little channels in between the ports. That sucker sealed up real good. And then I gave myself a bunch of extra line, just in case we want to make a placement somewhere away from the motor that you can't see. Anyhow, we're going to go ahead and put it together now. Okay, she's sealed up nicely. In 24 hours I'll come by and I'll peel off the extra gasket on the outside. You cut it with a razor blade nice and gently, and it'll leave a perfect seam. You won't see any of that excess. Just a really beautiful cover overall, and we have a vent that now is placed in the top.
Alright, so it is the next day, and got that sealed up. Got to scratch off a little bit of the sealant there, but it's all cleaned up. And we're going to put 60 milliliters of ISO 68 gear oil in here. Normally calls for 45 or something like that. We're going to put a little bit extra because it's going to end up filling up those pockets down there a little bit. So we're going to add that. And then we're going to get to test fitting this motor and figuring out the mounting. We're going to have to modify this motor a bit to get this Heim fit right in there. So already started a little bit and I forgot to come forward. So anyhow, let's get it done. Alright guys, so in a nutshell, this is basically what we've got. We've got our push and we've got our pull. We're going to go ahead and make a bottom connecting pivot here, which is going to be a bit complicated. We're probably going to make that out of steel because it's complicated and stronger. So basically, what I need to do now is I need to find out where to put that pivot so we can get that chain mostly tight with this all the way in. That way we can suck up the slack after the chain's been broken in to be able to have the travel necessary. I've already done the calculations on the gearing with that rear sprocket, and this is a 14 tooth front sprocket, so it should be around 45 to 50 miles an hour max speed. In a sidecar, that is absolutely enough. These things are dangerous as hell. But I may make a bracket here with multiple mounting holes. So we can change that if we want to run a bigger sprocket. So we'll see where that goes. But for now, I think we're going to go ahead and start working on this mount down here. Also, I may put something here to brace between here. And if I do, this will have probably slots in it so it can be adjusted just to give it a little bit of extra rigidity. Okay, so I may do something a little different. Made a little block here to line the motor up exactly with the this bolt here for the brake, And I am always stuck in the thinking of making everything bolt on, which typically makes things much harder to do. And I'm not going to do a mount from here down to here. I'm going to make some tabs. I'm going to take a steel rod, I'll drill a hole through, I'm going to weld them to the frame. I have this same paint, so you won't be able to see the weld. It's going to be 10 times easier, and we're going to be able to use this as a proper stationary pivot. Instead of doing some custom block and some custom difficult mount, I'm just going to weld it to the frame. Again, I'll use what looks to be, I think that's roughly 3/4 inch. I'll take some steel rod and I'll drill holes through it, run it on the lathe, and I'll weld the actual steel. It's basically a steel spacer that will be welded to the frame in the precise location. We can stick a bolt through it and call it a day. It'll be perfect pivot point, and then those things will work as they're supposed to. Also, it will capture the rigidity, and we won't even need these front mounts. So we can use that to mount a facade to cover everything up to make it look really nice. Here's something cool. We got a new machine to make processes a bit faster in the shop. This is a torque vectoring tapping machine. Also good for chamfering. Let's see if we can get zoomed in on there. Got a nice little tip for chamfering. The vise is set up to where this is perfectly parallel. So all we need to do is turn this baby on, come down, and that will clean up our holes for us. Alright, we've got our spacers and they fit super nice on this stainless steel 3/8 bolt. And they're even pretty. So I have to drill the motor out because that's a 7/16 hole, not 3/8. I'll need to drill that motor mount out just a tad bit to get this thicker stainless steel bolt in there. I love using stainless steel hardware. It's very strong, stronger than most standard steels. Grade 8 is obviously very strong, but stainless does not corrode. Grade 8, pretty good. They got a good coating on there. I just prefer stainless when I can use it. And I could absolutely get away with the 7/16 bolt on there because there'll be no gapping in between it. So it's literally relying on the shear strength of the bolt. However, I like bigger stuff, so we're gonna do that. We're gonna go ahead and pull the motor off, drill it out, and then we'll set it in on these spacers and see how it looks. So I did already drill out the other holes here and here. I'm not sure if you can see those in the video. Hopefully you can. I didn't want the video to be everything machining, so I left that off camera, but I'll show you how we did it at least this one time.
The reason why you want to do this on a drill press is because you want that hole to be perfectly straight. If it's not, the motor will be crooked. Okay, we're back over here at a bench. Time to test fit. So we know that we want the shorter spacer on the sprocket side, longer spacer on the other side. Doing this one-handed is not exactly the easiest thing to do. There we go. Got enough room for a bolt. Alright, now we will test fit that in the bike. Sweet, so we've got that in there. So the little block that I made, I'd customized it a little bit so it could push out and touch the other side so we can use this bolt as alignment. I looked at the bolt. The gap right between that bolt and the frame looks really, really straight. So I'm going off of the brake lever bolt to align the motor with the frame. So those spacers fit perfect. Plenty of meat on those little things to weld them on both sides. The motor is aligned quite nicely. I have this cinched all the way down so it's in the smallest position. The chain still has a little bit of slack, which is really good, so we can tighten that all out. Right now I have this pushing and this, so this pushing and this also pushing, so it torques the motor. That way we can get that straight with this block. I am going to pull this all back out. I'm going to use a white marker and mark where I'm going to grind off the paint so we can weld those on. We'll get the welder out. We're just going to tack those on, and then we're going to test it out. Let's go ahead and look at the other side before we do that. Also, I'll show you guys the chain alignment. It's not going to focus probably down there, but it's fantastic. You can see it a bit, kind of just a facade or what do they call those? A mirage. But yeah, it looks really good. Come over here to the other side. I'm sliding around on my knees like a goofball. That worked out really good. That spacer's also in the perfect spot, so we can weld that on. And everything seems to be aligned perfect. Once we get that tack welded on, we can pull all the other stuff out and really test the range of motion. Okay, we got the motor out. Put little white marks where we need to grind on both sides. You can see them here and here. They're in exactly the same spot on both sides, which tells me that it's definitely aligned because these tabs that they have here are also aligned. Those tabs were used for the kickstand stop. They're supposed to hold up the weight of the bike, so they are plenty strong. They look like they are roughly 3/16 bent steel, and they're welded onto the frame in multiple locations. So we can weld directly to those for this lower motor mount and it'll work perfectly. So we're gonna go ahead and get this ground down, and then we'll get the welder out and we're gonna tack it on. Okay, I got both sides grounded down, protected the frame with some tape. Didn't nick anything, luckily. I had to move it off of the rest stand and put it on the regular kickstand. That way I can get to everything. So we're gonna go ahead and put the motor on and put everything back, and then we're gonna tack weld it together. Okay, we've got it tacked in there on both sides. We're gonna go ahead and remove everything and see if she pivots like she's supposed to. We've got a beautiful pivot point. We're gonna go ahead and put those tie rods on and cinch it down and have a look. All right, guys, there it is. She's locked in. She doesn't move at all. Incredibly rigid, and the chain alignment is perfect. The pivot point worked great. I'm glad we went this way instead of making a custom pivot point in the back off the rear mount. That mount's not very beefy. This is much stronger, and with this setup, we could even do away with this one if we wanted to. But I like to do things a little bit overkill, so we're gonna leave it in there. However, if we do need to run a larger sprocket and that has to come out too much, it's still possible to run it without it.
The very next step is going to be making spacers, getting these bolts all the right length. We're going to put spacers in between every little section here, that way everything can be clamped down. This is the only one that's not going to get a spacer because it doesn't need it. There'll be a spacer on this one. There'll be a spacer on this one. We'll trim the bolts down that are too long, or we'll get the appropriate bolts, of course. And then we're going to move on to the battery, figuring out the size of the battery, what shape we're going to make it, and how we're going to mount it.
Alright guys, so that's it for this episode. If you want to see more, don't forget to like and subscribe, and stay tuned.